Okay, hi everyone. Thank you for coming to our session. My name is Tongbo, and this is my colleague Zhaoyan. We are security researchers at StackRocks, and for our company, we build the security tools to protect the container world, and we deliver container native security platform that prevent threats by reducing the attack surface. And today, definitely, I will talk about the container security. So it's called KubeScope for the extraordinary world of containers. And in this presentation, I will start with some introductions about the container security, orchestrators, and also especially for the Kubernetes. And then I'm trying to explain what is the current problem that is facing by the container world. And then is our solution to solve this problem. And at the last, there will be a quick demo there. So for the introduction, I will start with two numbers here, and which is revealed in a recent survey. So it shows that enterprises of all sizes are increasingly using containers. By 2020, more than half of the global organizations will be running containerized application in their production. And more importantly, the majority of them are deploying and managing their containerized production using orchestration software. And among all of the orchestration softwares, Kubernetes is definitely the dominant one, which has been adopted by 71% of all of them. And they can be used to managing their container infrastructure. So the Kubernetes is just the open source tools developed by Google, and it provides a container-centric management environment, and it's very portable and flexible to use. I think most of the people, if you work in the same area, you should be familiar with the Kubernetes. And however, the problem is that when Kubernetes and those orchestrators become the center of the new infrastructure, it also becomes the major target by attackers. And here's a figure here shows why the security of orchestrators becomes so vital in this new environment. In the most of the time, the attack happened from the pod where you are running your microservices. For example, if attacker can take advantage of command injection vulnerabilities in your web application, they can inject arbitrary code in your pod and execute those commands in your pod. But at this time, the damage is limited because the container sandbox, which isolates the compromised content in your pod from the rest of your cloud. And the next move of attackers should try to break out of this sandbox. And basically, there are two ways in front of them. They can either compromise the underlying operating system, or they can compromise the orchestrators here. That is two major targets here. Let's take a look at the first way. So if they can manage to exploit a kernel vulnerability, they can take over control the whole the host. So they can they can do whatever they want, like compromise other containers pod running in the same host. And we don't need to worry about those things because the operating system running in the cloud native environment has no big difference from the operating system in our daily life. And there are many tools out there can help people to protect and detect those attacks to the operating system. People can easily deploy them and prevent those attacks. So we are more interested on the second way. The attackers can compromise the orchestrators here because orchestrators like Kubernetes, they provide a rich for communication between the pod and some core part of the Kubernetes core component. And if attacker can managing to compromise the orchestrator, they can not only control the pod containers running at the same machine, but also the ones that are in the other machines deployed by the same orchestrator. And that is the reason why the security of Kubernetes, the security of those orchestrators is so important in this newly emerged container-based environment. And what makes the things worse is that there's no such a tool specifically protect the orchestrators. And that's the reason why we conduct our research and try to solve this problem. So we design and implement the KubeScope, and we leverage a combination of machine learning and rule-based detection techniques. And basically, we do a profile based on the normal access to the Kubernetes. And then for each new access to the Kubernetes, we will try to use our machine learning model and a rule-based model to detect the abnormal access. And for our prototype, we only protect the API server, which is a very centralized place in the Kubernetes architecture. And since all of the interaction to the API server is using the RESTful API, it's basically the HTTP-based traffic, and the access here we mean is the network traffic. So here's the figure to show that where our KubeScope component located in the whole Kubernetes architecture. And basically, it's located between the API server and the rest of the Kube system. So every traffic to the API server must go through our KubeScope component, either it's the HTTP or HTTPS. So basically, our KubeScope component will inspect all of the traffic to the API server and try to mark the abnormal ones. So if we double click into the KubeScope architecture, it's highly containerized. So each component here is a container running in the system. So we have a monitor container which will intercept all of the traffic to the API server and pass the request and put it into a queue. And later on, the machine learning module here, the Kube inspector, will get a feed from the queue and try to identify the abnormal ones. So this module will also put the result back to the queue and also to the backend to the backend storage. And we also provide a user interface for users to monitor what exactly happened in their Kubernetes system, who is interacting with the API server, and what the exact traffic is. And also they can clearly see where is the abnormal access here. And next is the Kube inspector module. My colleague Zhaoyan will take over and explain more detail about it.
Kube inspector is actually a component which exists inside of the KubeScope, and this component is mainly take care of detecting logic of the KubeScope. So the input of the Kube inspector is the decrypted and the normal HTTP request from the clients. So the normal here is basically simplified that the Kube inspector's method is a profile-based method, which basically means it's a profile all the normal behaviors of API servers. So the normal behaviors here we refer is the normal access from each different ports to the API servers. And the output of the Kube inspector will be the models, the models including both the machine learning models and also the rule-based models to profile the normal Kubernetes access. So here, I list the example here is how we actually extract the information from the normal Kubernetes request to the API servers. So here we extract the four parts of the informations. First is the URL and its parameters. The second is URL itself. And the third part is HTTP headers. The HTTP headers including all the keys of the HTTP headers and also its corresponding values. And the last part is the request bodies. From our experience, we see a lot of request bodies including JSON objects, which is issued from the pod to the API server to execute the new functionalities. So this is an example I want to show how we extract informations. So after we extract all these kind of informations, we'll analyze each request in 3 levels. First is the URL and its parameters. The second is HTTP headers, and the third is the payload methods. We want to propose different kind of models for each different API calls, which basically means, for example, if Kubernetes offers different kind of service, different kind of service for their API calls, we'll build one model for one API calls. So for models, we actually build 3 types of the models. The first type of the models, we call it unknown access models. That's including something like an unknown URL, unknown parameters for URLs, unknown user agents for the HTTP headers, and also unknown content type. So we list some explanation here. The basic logic is if we find any kind of URL or parameters which is not being seen before, we think it's a possible abnormal access. The second type of the model, we call it invalid ss models. So invalid basically means the contents of the request may contain some abnormal or possible malicious payloads. So here we list the invalid parameters, invalid cookie values, and also invalid payloads. We will detect whether they have some like shellcode or malicious file or malicious script inside of these kind of things. And then the last part is based on the machine learning. We call it abnormal access models. So here we list 2 examples. Here is the statistic models, which we will profile all the like a normal packet length, parameter values length, and cookie values length, and also the number of parameters. So if we find any kind of the request that have abnormal behaviors, like they have a super long packet, and also like the value is super long, the abnormal statistical model will actually trigger and file abnormal signals. And then the next part is the access frequency model that actually we will record the normal frequency of the incoming packets. So if any kind of packets come in abnormal frequency, we will also trigger alert. So here we list several like rules here to illustrate how we actually determine whether this request to the API service is abnormal or not. In the following demos, we will demo some like reasons listed here in the bold letters. And here is a detailed illustration of how we detect whether it's abnormal things. For example, if it's a URL parameters, we will check whether the URL's key is known or not, whether the value is a valid type. For example, it should be a string, int, or IP addresses. And also, we will think whether this value is too long or not, whether they have some possible SQL injection or not. It exists in these parameters. And also, similar things we will do for the request body to see whether this request body is abnormal or not, whether they have some known keys or values, and whether they contain some shellcode, and also whether they have some malicious file included in the request or not. So next, Tongbo will show all you guys some demos we have present here.
Okay, so Zhaoyan just discussed several reasons we may detect the abnormal request. And so there will be several demos. The first demo is to detect the compromised secret in a pod. And so the scenario is that, say you have a pod running your Kubernetes, and by default, the Kubernetes will mount the service account secret to your pod. If it gets compromised, the attacker may trying to leverage this, will try to steal these tokens from your pod and use this token to access your API server and achieve a further damage. And because our KubeScope will locate it in front of the API server, and so it will intercept such a request from the generated by the attacker. And since this pod itself, it rarely make such a request to the API server we will identify this as a malicious one. So here, so here is a video to show our attack. We launch a Kubernetes in the local, and then see you can see there are some traffic already been intercepted, and then I will try to launch the web application, which is definitely a vulnerable one. It's a web application. Okay, it's being launched, and also the service account token is automatically mounted to that pod. And here is the dummy, the vulnerable page, and from these figures here, whatever you post from this form will get executed. So I put several code here at the third, so at this input field is basically it's just steal the service token in your pod and trying to send a request using this token. So see the request has been successfully be launched, and we get detect one of the abnormal request, and release the request here. So here is we just if we double click into this abnormal request, it's generated by the attacker and trying to use the stolen token to access the API server, and because it used valid token, and but it shouldn't be used by this pod, and then we just mark this as an abnormal one. And the second demo is quite simple. It's just the DDoS attack. So the scenario is like the attacker may generate a burst of a request to the API server, because the API server used the RESTful API for each request. It may just process it many times, and the request may be launched from the pod or from the attacker itself, and then our KubeScope component will get this will intercept those requests, and one of the feature we extract from the request is the time. It's a timestamp. So usually the communication between the worker node to the master node is quite periodically, including the healthy check, the pod management request is periodically. But such a DOS attack request, they will be just be generated in a short period of time. It will trigger the abnormal. It will be marked as an abnormal request due to the timestamp feature. And the demo is also very simple. So I will just using a Python script to generate a bunch of requests in a short period of time, and then it will be marked. So like I just mentioned earlier, and it will be detected and prevented in our KubeScope architecture. So as I mentioned earlier, because one of our feature in our machine learning model is those timestamp, and we will also show the reason why we mark is as abnormal. It's a frequency of package coming is abnormal. So that is the detection reason here, and I think probably that's the all of my presentation. If you have any questions, please feel free to ask. And thanks for your coming to our session.